What if the air you breathe once hid a deadly lie? What if fire itself was misunderstood for centuries? And what if everything we know about reality is about to change? Throughout history, science has shattered illusions. Theories once hailed as truth collapsed overnight. Today, we're diving into the explosive moments when science flipped the script and how those revolutions might hold the key to unlocking our universe's deepest secrets. Let's see. Hey everyone, I'm Arun Babu, an IIT Bombay alumni who spent years exploring the mysteries of the cosmos. For decades, one question has kept me up at night. How do radical ideas go from heresy to textbook? Today, let's rewind to four shocking scientific U-turns that rocked our world: Phlogiston, Miasma, classical versus quantum, and steady state versus Big Bang, and see what they reveal about embracing new frontiers in science. In the 1700s, scientists believed a fire-like substance called phlogiston caused combustion. The wood burns, phlogiston escaping. It sounded logical until Antoine Lavoisier questioned it. He painstakingly weighed ashes and gases, finally revealing it's oxygen that fuels flames, not some mystical element. In one swoop, phlogiston was torched, a testament to how ruthless experimentation can vaporize even the most certain ideas. Miasma. For centuries, disease was blamed on bad air or miasma. From plague doctors in beak masks to citywide fumigations, everyone feared the noxious clouds. Then Louis Pasteur and Robert Koch peered through microscopes and found a shocking truth. Microbes, not foul smells, cause infections. Overnight, modern medicine was born. Suddenly, hand washing, vaccines, and antiseptics became lifesavers. It's hard to imagine, but talk of invisible germs once sounded as wild as saying there could be life inside an electron. Yet here we are, classical versus quantum. Newton's laws worked great for planets and apples until we zoomed in on atoms. Then it all went haywire. Particles that acted like waves, electrons that could be in multiple places at once. Even Einstein called it spooky action. This bizarre world known as quantum physics shook the very bedrock of classical determinism. Yet it paved the way for lasers, computers, and even nuclear technology. Sometimes the universe is far stranger than we'd ever expect, but we only discover that when we dare to question. Steady state versus Big Bang. Lastly, the cosmic face-off, steady state versus Big Bang. Back in the 1950s, many scientists believed the universe had no beginning. But then astronomers detected cosmic microwave background, the echo of a colossal explosion. In one stroke, the universe got a birthday. This dramatic twist tells us that sometimes even cosmic architecture reveals surprises that can't be ignored once the evidence shows up. So what do these revolutions teach us? Truth is a moving target, and today's lunatic theory can become tomorrow's scientific bedrock. Remember, people called germ theory ludicrous. They scoffed at quantum weights, yet each time bold observation won. This is why we're testing big ideas in this series, including the notion that electrons, or even subparticles, might host entire realms we've never imagined. Does that sound radical? Absolutely. But so did microbes once. And while I'm not ready to unveil all the details of the layered density structure LDS theory, we'll keep building the case step by step. If evidence leads us there, maybe we'll someday rewrite textbooks again. If these dramatic scientific revolutions struck a chord with you, hit that subscribe button and ring the notification bell, so you don't miss our deep dives into the unexplored frontiers of science. Comment below, which past impossible theory do you find most fascinating? Let's spark a conversation on how bold, unconventional ideas can change everything. In our next video, we'll explore why it's essential to keep our minds open to new theories, even when they challenge our comfort zone. Until then, stay curious, stay open-minded, and remember, every breakthrough was once a radical notion.